Hi friends, this is Dr. Shivnagareddy and we are going to see applied physics objectives for first mid exams for the first year B.Tech student for regulation R-22. In this series, this is the third part. The first part related to the exam pattern, theory as well as practicals and important questions related to theory. When second part deals with Viva questions related to practical exams. This third part deals with the objective questions for the theory paper and the objective questions will be for 10 marks in the exam. So question number 1 is light waves are longitudinal wave, transverse wave, both A and B and none of them. Light waves are transverse waves. Second one, which one of the following does not support the wave nature of the light? So in this total thing, interference, polarization and diffraction support the wave nature of the light, and this Compton effect won't support the wave nature of the light. Now colors in thin films are because of dispersion, diffraction, interference. None of interference is the reason for the colors of the thin films. A phase difference pi between two interfering beams is equivalent to path difference. Now we have to know the relation between phase difference to path difference. So phase difference is equal to 2 pi by lambda into path difference. So here we have to calculate the path difference. So if we write as a path difference, then it will be lambda by 2 pi into phase difference. That phase difference is pi, so pi will get cancels. The answer for this one will be lambda by 2. Now in reflected light, the central fringe of Newton rings. So in the Newton rings experiment, the central fringe will be always dark. In a Newton's ring experiment, the diameter of the bright rings is proportional to square root of the natural numbers. The extended source is used in Newton's rings experiment only. Then intensity of a light is proportional to square of the amplitude. So I is directly proportional to k square. Which one of the following device cannot produce a coherent beam of light? So in this we use different methods to produce a coherent beam, especially Fresnel biprism, Young's double slit, Lloyd's mirror, Newton rings, thin film interference. But this is a half shade polarimeter is related to polarization. The following methods are based on the division of waveplane. We have two ways we will use. One is a division of wavefront. So basically for the division of wavefront, we use Fresnel biprism, Fresnel mirror, Lloyd's mirror, lasers, etc. When come to the division of amplitude, there will be interference in thin films, Newton rings, Michelson interferometer. So in the present scenario, which of the following methods are based on division of amplitude? So when come to the division of amplitude, we have only one experiment. First one Newton rings and second one is also based on the division of amplitude. So answer will be the C. Next one, which of the following methods is based on the division of wavefront? So based on the division of wavefront, we have Fresnel biprism. Phenomena which cannot be explained by wave theory of light is. So in this four objectives, interference, diffraction and polarization, we can explain with the wave theory, but this is the only one effect, photoelectric effect, which will be explained based on the particle nature of the light. Which one of the following the interference is produced by division of amplitude? So we have Newton rings as a part. In a Newton's ring arrangement, bright and dark rings are obtained using sodium yellow light. What happens if the top surface of the glass plate on which the lens is kept is highly silvered? So whenever we made a silver that glass plate under this plano-convex lens, then fringes will get disappear. So we will go for the next one, and here a quote: you don't have to be great to start, but you have to start to be great. So unless we start, we won't move further. So we have to start somehow and move ahead in life as well as in studies. Then come to second part. The diffraction phenomena is. So it is a well known. The diffraction is nothing but bending of a light around the obstacles. So this is the option A. Then to find the prominent diffraction, the size of a diffracting object should be it should be in the order of wavelength of the light. This is the basic and one of the important condition in order to get a prominent diffraction. So in a Fresnel's diffraction, we have a two types of diffractions, Fresnel and Fraunhofer. So in a Fresnel diffraction, basically source of the light is kept at a finite distance from the aperture. If we keep at infinite distance, then it is a Fraunhofer. And in Fraunhofer we use the lens, but in Fresnel we won't use the lens. Then in Fraunhofer diffraction, the incident wavefront should be. So in a Fraunhofer diffraction, plane wavefront is the wavefront which we use. So in the Fraunhofer diffraction, generally source will be at infinity, but in the lab, if we are doing any experiment related to Fraunhofer diffraction, by using the lenses, we will convert a point or spherical wavefronts into plane wavefronts. Then in the diffraction pattern using circular aperture, when the screen is brought towards the aperture. So this may not be in our syllabus, but the answer will be many points are observed where greater intensity is found. Next one, significant diffraction of X-rays can be obtained. So significant diffraction, so that's the basic condition is we have to take in the order of angstroms. That's the only chance is by atomic crystals. Maximum number of orders found with the grating is the wavelength of a particular color equal to A plus B, which is a grating element, into sine theta. So this is a directly proportional to the grating element. Then the resolving power of the grating increases. So resolving power of the grating, the formula will be lambda by d lambda equal to n into capital N. So where small n gives the order, then second one, capital N gives the number of lines on grating. As the number of ruled lines per centimeter of grating increases, the resolving power increases. In a plane diffraction grating, width of a principal maxima increases as the number of slits increases. Which of the following statement is correct if the width of the slit is reduced in a single slit experiment? So once we reduce the intensity, the width of the slit, the intensity of the fringes larger, the thickness of the fringes reduced, the thickness of the fringes increased. This may be the none of these. Then which one of the following color will be diffracted more when white light is used? Red will get more diffracted and violet will get less diffracted due to it's a shorter wavelength. So red has the largest wavelength, so it is diffracted most. Violet has the shorter wavelength, so it's less diffract. Then the resolving limit of normal eye, 1 by 60 degrees. Then which of the following relation is true for the limit of a resolution of a telescope by 1.2? Then which one of the following phenomena tells about a transverse nature of light waves? So interference, diffraction, polarization, photoelectric effect. We already know interference, diffraction and polarization will tell the wave nature of the light, and in that also whether they are transverse nature or longitudinal nature, interference and diffraction cannot tell, only polarization will explain that one. Then plane polarized light has vibrations, one plane, one direction perpendicular to the direction of propagation, one direction perpendicular to the direction of propagation. Polarized light can be produced by, so we can produce polarized light by reflection, refraction, double refraction. So this is all of them. At a polarizing angle, the reflected angle and refracted angle makes an angle of 90 degrees. So then Brewster's law in terms of a refractive index, mu equal to tan IP. Then according to Malus law, the intensity of polarized light emerging through the analyzer varies. So it is basically Malus law is I is equal to I naught cos square theta. Malus law, intensity of polarization light emerging through the analyzer varies as I naught is equal to cos. Then Malus discovered a simplest method for polarization of light by reflection in the year 1808. Which one of the example is uniaxial? Calcite is the uniaxial crystal. We will go for which one of the example is a biaxial crystal. Storm light, this one will come there. So this ninth, what happens if ordinary unpolarized light is passed through a uniaxial crystal? It enter into the uniaxial crystal, light is split into two rays. One is ordinary ray, another one is extraordinary. So what happens to ordinary extraordinary rays if they travel along the optical axis? So whenever they are traveling along the optical axis, they both will travel with the same velocity, so there is no, the substance that is capable of rotation of plane of vibration is known as optically active. So if two polarizing and analyzing Nichols are, Nichols stands for Nicol prisms, at 90 degrees, then the emergent light passes through the analyzing Nichols becomes. So we have to use this one, I is equal to I naught cos square theta. If theta is 90 degrees, the answer will be 0 will come. Which one of the following phenomena cannot be explained by the classical theory? So in that, photoelectric effect, Compton effect, Raman effect, black body radiation, all these things are not explained with the help of classical theory. Which one of the following phenomena shows a particle nature of the light? So when come to photoelectric effect, Raman effect, Compton effect, all these three shows the particle nature of the light. Wien's law is deduced from Planck's radiation formula under the condition of is derived based on a very small wavelength and temperature. This is related to black body radiations. When come to Rayleigh-Jean's law is deduced from Planck's radiation formula under the condition of large wavelength and high temperature. Which one of the following characteristics of photons have? Photon have rest mass 0 equal to h nu, m is equal to h nu by c square. So photon is nothing but light particle, consists of all these properties. So which of the following relation can be used to determine a de Broglie wavelength associated with a particle of mass and having energy? The phase velocity of de Broglie wave associated with the electron behaves like a wave as it can be diffracted by a crystal. So in a Davison-Germer experiment, when a material particle is in thermal equilibrium at a temperature T, the wavelength of de Broglie wave associated with is, so 2 pi m k T. This one is to be correct, but pi is missing, 2 pi m k T. Then photoelectric effect involves only, so basically it is involves about the bound electrons. De Broglie hypothesis is concerned with the wave nature of all material particles. Then dual character of matter was proposed by de Broglie. Davison-Germer proved the de Broglie nature by doing Davison-Germer experiment. Planck introduced a Planck law equal to NH. The existence of matter wave is experimentally proved by Davison and Germer. Raman did the Raman effect when de Broglie proposed a de Broglie hypothesis. Quantum theory successfully explains the phenomena of it is able to explain almost all the phenomena like photoelectric effect, Compton effect, interference, diffraction, polarization, black body radiation. So it's all of these. Matter waves, so diffraction, interference, polarization. So basically they will show matter waves are similar in nature too. Their nature is electromagnetic waves. Target material in Davison-Germer experiment. So in Davison-Germer experiment, they used a nickel crystal. With the increase in the temperature, the resistance of the material increases. Then metal obeys Ohm's law, have high electrical and thermal conductivities, resistivity in proportional to temperature, and all the properties. In the presence of applied field, the average distance traveled by an electron between two successive collisions is known as mean free path. Then which of the following is the correct Ohm's law? So that is a J is equal to, the free electron theory of metals was initiated by Lorentz and Drude. Which one of the following theory was developed by Lorentz and Drude? That is nothing but a classical free electron theory. Quantum theory of free electrons in a metal explain electrical conductivity and thermionic emission, specific heat and paramagnetism. So both A and B. The eigenvalues of a free electron model is equal to h square k square by 2m. The first Brillouin zone is defined between the first Brillouin zone is defined between the regions how to see in one dimensional, that is a second Brillouin zone. Minus pi by a2 plus pi by a is the first Brillouin zone. Second Brillouin zone contains two parts. It is a minus pi by a2 minus pi by a, pi by a to 2 pi by a. Then Bragg's condition for a diffraction is given as 2a sin theta is equal to n lambda, where a is a interplanar spacing, theta is the incident angle, n is the order, lambda is the wavelength of incident ray. So which one of the following relation is correct for the effective mass of the electron? So whenever electron is moving in an electric field, its mass will be different from its regular mass. So m star will be h cut square 4 pi square into d square e by dk square whole power minus 2. When we increase the temperature of intrinsic semiconductor, after a certain temperature it behaves like so. We increase temperature, that extrinsic semiconductor will act as an intrinsic semiconductor after breaking the bonds. Then pure semiconductor behaves as an insulator. At coefficient is given by the relation RH is equal to minus 1 by N. Which type of semiconductor materials has a Hall coefficient negative? So basically N-type semiconductors has a negative coefficient. The electrical conductivity of a pure semiconductor at 0 Kelvin is. Then which of the following theory proposes about the free electron inside a periodic lattice? So basically periodic lattice is introduced in case of zone theory, proposed by Bloch and further modified by Cronin and Penny. The electrical current in an intrinsic semiconductor is because of, basically it's an intrinsic semiconductor, both electrons in conduction band and holes in valency band. Next one, the majority carriers in N-type semiconductors are electrons in conduction band. By doping a fifth group element in germanium crystal, which type of semiconductor material is obtained? If we are doping fifth group, we will get a negative. Then if we go dope third group, we will get a positive. That's nothing but a p-type. In an N-type semiconductor, the Fermi level lies. In a intrinsic semiconductor, Fermi level will be at a middle, but if we go for the N-type semiconductors, the Fermi level will be below the bottom of conduction band, and on the increase of a temperature, the Fermi level shift upwards in P-type semiconductor. The energy gap between the valency and conduction bands in a semiconductor is order of 1 electron volt. In the absence of a potential for Cronin-Penny model, in the absence of potential for Cronin-Penny model, what will happen? That forbidden energy regions are present. In the absence of potential barrier, decay curve is parabola with discontinuities. Then the discontinuous occurs in EK curve at E is equal to n pi by a. Then the effective mass of an electron may be positive, negative or infinity. So all are correct. When come to the Hall effect is used in determining mobility. So all of these relations are valid. Heisenberg uncertainty relation holds good for the energy of the particle and infinite potential value. So energy of the particle in infinite potential will be n square pi square h cut square by 2m. Energy En is directly proportional. Which of the following energy values of the particle in infinite potential value of length L? Length is given in terms of L. So n square pi square h cut square by 2m. Then the entire information of quantum system can be gathered with the help of wave function. So if we know the wave function, we can apply different operators in order to extract the complete information. The expression psi modulus psi x comma t whole square stands for, it's a positional probability density. Then if psi is a normalized wave function, then the value of minus infinity to plus infinity psi star psi dv will be, so it will be 1. That's the normalizing condition. Then which of the following relation is correct for Schrodinger wave equation moving along x direction? So Dou square psi by dou x square plus 2m by h cut square e minus v into psi. Psi by dou x square plus 2m by h cut square. Then the wave function psi associated with matter waves has no direct. Basically, it is a complex quantity. It is not observable quantity. Directly, we cannot measure what is psi. The normalized eigen wave function of the particle in a box of length L. So psi will be root 2 by L sine n by x by L. This is root 2 by L sine n by x. The energy levels of a particle in this box are basically the infinite 1D box. The energy levels are not equally spaced. Only harmonic oscillator has equally spaced particles, and when come to the continuous energy, there is no role of continuous energy in quantum. Today's class, and these are the objectives. We have to revise number of the times so that we will get a good marks in the exam. All the best. Have a great day. See you.